AI safety and security vulnerabilities. The cat-and-mouse game between AI safety researchers and adversarial attackers took a significant leap forward with the introduction of the first gradient-based untargeted jailbreak attack, UJA, against large language models. Published by researchers from Zhejiang University, NTU, KAUST, and other institutions, this work addresses fundamental limitations in existing jailbreak methodologies that have constrained attack efficacy for years. The core insight is deceptively simple. Existing gradient-based attacks force LLMs to output predefined affirmative prefixes like sure, here is, but different models have different natural response patterns. Llama 3, for instance, typically begins responses with here rather than sure, which means the standard attack target is already fighting against the model's learned distribution. This mismatch results in the well-known GCG attack, achieving only 50% attack success rate even after 100 optimization iterations. The UJA approach instead operates without a rigid target prefix, dramatically expanding the search space and reducing computational overhead. The distinction between white box attacks, full parameter access enabling gradient exploitation, and black box attacks, query-only access, remains crucial for understanding the threat landscape. White box methods like GCG use greedy coordinate descent for adversarial suffix optimization, while cold attack leverages Langevin dynamics for gradient-based sampling. The new untargeted approach could potentially be applied across both paradigms, raising concerns about the scalability of defensive measures. On the defensive side, ServiceNow released AprilGuard, an 8B parameter safety model designed to detect 16 categories of safety risks, plus a wide range of adversarial attacks including prompt injection, chain-of-thought corruption, and memory poisoning. What makes AprilGuard notable is its explicit design for agentic workflows. It can analyze tool calls, reasoning traces, and memory contexts, addressing the reality that modern LLM deployments involve multi-step reasoning and external tool integration. The model operates in both reasoning mode, explainable classification, and non-reasoning mode, low-latency production inference, acknowledging the trade-off between interpretability and speed. Meanwhile, Cisco's MCP scanner received a significant update with behavioral code scanning capabilities specifically targeting backdoored model context protocol servers. The motivation is practical. Enterprise security teams face teams deploying arbitrary MCP servers from the internet that may have been compromised. One cited example involved attackers backdooring a Poshmark MCP server to BCC all emails to a hard-coded address. The scanner uses a hybrid approach combining static analysis techniques, call graph analysis, data flow analysis, reverse taint analysis, with LLM-powered semantic understanding to detect mismatches between tool descriptions and actual implementation. This represents a meaningful evolution from rule-based SaaS tools like Bandit, which struggle with the semantic complexity of detecting when get weather in California code also exfiltrates/etcd past WD. On the offensive tooling side, Pentest GPT hit version 1.0 with a complete architectural rewrite implementing an agentic pipeline with a 5-state lifecycle controller, event-driven architecture, and Langfuse integration for observability. Local AI infrastructure and deployment. The local inference community continues pushing boundaries, with a particularly impressive demonstration this week. A fully offline AI agent running entirely without external APIs that noticed and fixed a bug in its own GUI, specifically that a panic button was invisible due to black text on a black background in dark theme. The agent reasoned about the problem and implemented a fix autonomously. The developer's approach to context management is worth noting. Rather than dumping entire codebases into the context window, the agent uses tools to read specific files on demand, mimicking how human developers actually work. This scales well for modular projects, but hits limitations when single files exceed 10K plus lines. The hardware side of local AI got an entertaining demonstration involving a Raspberry Pi 4 orchestrating a wake-on-LAN setup for a multi-GPU server. The Pi sips roughly 4 watts in standby, then wakes a system with 256GB quad-channel RAM, 120GB GDDR6X VRAM, and 128GB GDDR7 VRAM across 7 GPUs, scaling dynamically. The setup idles around 150 watts with the dual Xeon CPUs being the primary draw. Comments noted the approach might seem overcomplicated, way too much fluff to just say, I used a for to do well. But the underlying use case, having local inference available on demand without running expensive hardware 24/7, addresses a real pain point for hobbyists with substantial GPU investments. Provider lock-in remains a persistent friction point for developers building agent systems. One solution gaining traction is A-Infra, a thin abstraction layer enabling seamless swapping between OpenAI, Anthropic, Google, and Ollama without code rewrites. The library bundles chat, streaming, tool-calling agents via LangGraph, RAG with SQLite or Postgres backends, and MCP client-server capabilities. When asked about the most useful tools in production agent deployments, file system operations emerged as surprisingly valuable. Simple capabilities like reading config files and checking paths handle edge cases that purely input processing agents miss. Structured output parsing with automatic retry logic also proved essential when models inevitably return malformed JSON. For creative applications, a Phoenix LiveView tool for batch image captioning using local Llama CPP demonstrates practical local deployment patterns, prioritizing existing EXIF data over LLM generation and only querying vision models when necessary. AI model architecture and performance optimization. A research team has achieved something that sounds almost paradoxical, turning autoregressive language models into diffusion-style parallel decoders while maintaining causality and achieving 4x speedup. The technique, called Jacobi forcing, exploits an insight that's been hiding in plain sight. The theoretical motivation draws from recent Anthropic research demonstrating significant pre-construction in hidden layers before autoregression begins. Essentially, models appear to predict the rhetorical structure of entire responses before generating a single token. As one commenter noted, the naive token-by-token generation model falls apart on basic questions. How do you pace an argument you don't know how will end? How many points should you make? The Jacobi forcing results consistently show 3 to 4x wall clock speedup on coding and math tasks, with only minor accuracy changes versus greedy autoregressive decoding, significantly outperforming both diffusion LLMs and prior consistency-based parallel decoders in accuracy throughput trade-offs. The question of whether this extends to reasoning tasks, fancier rhetoric, as one researcher put it, remains open. Separately, experimental work on variable-sized experts in mixture of experts architectures yielded nuanced findings. Built on nano-GPT with megablocks for efficient MoE computation, the experiments found that variable-sized models do train faster. A 23-to-1 ratio of large to small experts trains 20% faster with 2.5% higher loss, but this advantage disappears when compared against vanilla MoEs with equivalent average expert size. The practical takeaway confirms what DeepSeek v3 and Kimi K2 already discovered. The traditional 4x expansion factor for experts is unnecessarily large, with 2.57x proving more efficient. The more interesting finding concerns which tokens route to which expert sizes. Tokens in constrained contexts, code syntax, recipe formatting, route to smaller experts, while ambiguous function tokens like with and to route to larger ones. Earlier layers also route to smaller experts, more on average, particularly layer 0. The interpretation: when what comes next is more predictable, the model learns to allocate less compute. When it's ambiguous, more compute gets allocated automatically through the learned routing mechanism. Creative AI applications and interactive systems. A Unity 6 prototype demonstrates emergent behavior in virtual pet simulation using locally hosted Ollama models, with results that challenge traditional game AI approaches. Each creature in the simulation is fully AI-driven. The LLM controls all movement decisions, determining when to wander, eat, sleep, and interact. Green squares represent food, purple rectangles are beds. The creatures seek these resources naturally based on their evaluated needs rather than following scripted behavior trees. What distinguishes this from traditional game AI is the social dynamics layer. Creatures converse with each other and with the player, and these conversations affect memory, mood, and relationships. Tell one creature something, and it may influence how that creature talks to others. Direct commands like stop, follow, or find another creature aren't blindly executed, Creatures evaluate commands against personality, trust levels, current needs, and survival priorities before responding. The entire system runs on an RTX 2070 with 8 GB VRAM, making it accessible to hobbyists. The developer notes that watching emergent behavior form rather than scripting it has been wild. In audio AI, StepFun released Step Audio R1, claiming it as the first audio language model to successfully unlock chain-of-thought reasoning for audio understanding. Previous audio models suffered from an inverted scaling problem, where longer reasoning actually degraded performance, the opposite of what happens with text models. The root cause: models were engaging in textual surrogate reasoning, analyzing transcripts rather than actual acoustic properties. The solution: modality-grounded reasoning distillation (MGRD), iteratively shifts the model's reasoning from textual abstractions to acoustic features. The result reportedly surpasses Gemini 2.5 Pro and approaches Gemini 3 on major audio reasoning tasks, while also outperforming Qwen 3 on textual reasoning benchmarks. On the text-to-speech front, Mirates offers 48 kHz audio output at speeds exceeding 100x real-time using LM deploy and batching, operating within 6 GB VRAM with latency as low as 100 milliseconds. A community-created demo space allows direct testing without local setup. Open-source AI ethics and data rights. The relationship between AI development and open-source sustainability reached a breaking point that's been building for years, crystallized in a new essay arguing that LLM training data scraping fundamentally destroys the social contract that made free software successful. The argument centers on copyleft as a hack of copyright. By releasing work under open licenses, creators grant others the same rights they hold, enabling the collaborative ecosystem that produced Blink, WebKit, Linux, and Android. A Harvard study values open source at $8.8 trillion economically. The AI training dynamic breaks this bargain asymmetrically. Contributors to open projects share their work, expecting reciprocal participation in a commons. Big tech companies consume that commons wholesale for commercial training data, returning nothing to the ecosystem that generated the value. Mozilla's replacement of volunteer translations with AI outputs, using models trained on volunteer-created content, becomes a particularly pointed example. The scraping problem extends beyond code repositories. Anna's archive, typically focused on books and papers, reportedly scraped 256 million rows of track metadata and 86 million audio files from Spotify, with the data distributed via P2P networks totaling roughly 300 terabytes. Spotify confirmed unauthorized access and illicit tactics to circumvent DRM. The archive described the project as preserving humanity's knowledge and culture, though observers noted anyone could theoretically create a personal free Spotify equivalent using a media server like Plex. The only real barriers are copyright law and fear of enforcement. The sustainability crisis in open source got a concrete illustration when libxml2, a critical dependency for GNOME and countless web browsers, briefly became unmaintained after Nick Wellenhofer stepped down. Both the original author Daniel Veyard and Wellenhofer worked as unpaid volunteers even as large corporations incorporated the library into commercial software. Companies submitted bug reports eagerly but provided virtually no support, a single Google donation being the exception. Security vulnerability handling proved particularly burdensome. Drop everything, research the cause, develop a fix, establish a patch date, file a CVE. 2 new maintainers have volunteered, but the churn itself signals ongoing project health concerns. AI development tools and platforms. The Claude Code versus GitHub Copilot debate produced useful technical clarity this week when users dissected the actual architectural differences. The core distinction lies in context handling. Copilot compresses context through processes that reduce accuracy but enable Microsoft to offer Opus usage at lower cost. Claude Code maintains fuller context and can spawn specialized subagents running in parallel. One user shared a screenshot showing QA agents running simultaneously alongside the main orchestrator. The subagent capability proves particularly useful for task delegation. Spin up a TSQL specialist for database operations, a QA agent for endpoint testing, with the main Claude instance orchestrating handoffs. Users report RAM usage around 10 to 15 gigabytes for typical multi-agent workloads, with the caveat that these subagents work best for focused, limited-scope tasks rather than massive single changes. Copilot users have attempted similar orchestration patterns through tools like Copilot Orchestra, but the native integration in Claude Code appears smoother. The broader context matters. At roughly $2,000 per year more than Copilot, Claude Code needs to demonstrate proportional value. Users with substantial code bases report the privacy benefits. Code never leaving local machines and elimination of API latency justify the premium for production work. On the research automation front, an open-source tool claiming data in, research paper out, fully autonomous operation drew sharp criticism. Researchers characterized it as actively harmful to an already overburdened academic system, noting that such publications amount to get-rich-quick schemes in some circles. The better journals can raise article processing charges, arguing increased filtration needs, while mid-tier journals and our Xeve drown in AI-generated slop. The losers are non-academic readers who cannot distinguish freely available garbage from legitimate research. More positively, one thinker represents a serious attempt at all-in-one multimodal reasoning across image and video tasks, with capabilities spanning rule-based QA, captioning, spatial grounding, temporal grounding, tracking, and segmentation. Built on Qwen3VL Instruct 8b and trained with a novel RL method, reward STD normalization, that balances heterogeneous reward signals across diverse visual tasks, it achieves 70.6% on MMMU, 64.3% on MathVerse, and strong performance across 31 benchmarks spanning 10 fundamental vision tasks. Black Forest Labs also released Flux.2, a 32B parameter flow matching transformer for image generation and editing, with quantized versions enabling RTX 4090 deployment. Open versus closed AI model performance. The performance gap between proprietary and open-weight AI models is closing at a pace that's genuinely surprising, practitioners who've been tracking the space for years. GLM 4.7 just dropped. Minimax M2.1 reportedly arrives Christmas Day, and these models are becoming legitimate drop-in replacements for proprietary coding LLMs in tools like Claude Code, Klein, and Kilo. The practical implications extend beyond benchmark scores. Local deployment means code never leaves the machine. No agent exfiltrating code bases to cloud providers. API latency disappears, replaced by pure compute bandwidth. Vibe coding instructions make the UI feel jazzier, work alongside serious software engineering tasks. The commenter notes that running GPT-2 in GGML in 2023 feels like a decade ago, predicting 2026 as the year of the home AI data center. Skeptics raise valid concerns. Consumer hardware prices continue climbing as big tech absorbs GPU supply, potentially forcing users back to cloud services regardless of model availability. The minimum viable home inference setup appears to center around 2 to 4 24GB RTX 3090s for those not investing at 4DEX RTX 6000 levels. Others note the coming B200 shipments could further accelerate the democratization trend. The economic question looms large. If open models approach parity with proprietary offerings, what happens to the $600 billion in AI infrastructure investment? The alignment critique cuts deeper. Cloud AI serves the interests of the companies that own it, not necessarily the users. Whether this tension resolves through market forces, regulation, or technical progress remains unclear, but the trajectory toward capable local inference appears irreversible.